Hello everyone. Today we're going to discuss another example related to motion in one dimension, but this time it will be a motion vertically on the y-axis. So it could be an object will be dropped down, downward, or we're going to throw it downward, or we can throw it upward. So I will have different examples in different videos related to the same motion and vertically. So this example here asking me with what speed must a ball thrown upward from ground level to rise to maximum height 50 meter. And the second part of the question, how long will it be in the air? So as a start, I know that at the maximum height, the final velocity will be 0. I know that the maximum height it will reach is 50 meter, and the gravity acceleration is the acceleration, because the gravity is the only force acting on this object, will be negative 9.8 meter per second square, because the negative is representing the direction of the gravity acceleration. Now, to find the speed, must start this process. It's the initial speed. I can pick one of the kinematics equation where the final velocity squared equal the initial squared plus 2g, and I will say y because I am moving on the y direction. Now, as we said, this equals 0. The initial velocity, we don't know how much is it, plus 2. The gravity acceleration is negative 9.8. And the maximum height is 50 meter above the ground, so it's going to be positive. Just by rearranging our formula, that will make the initial velocity squared equal 980, but we are looking for the initial velocity, so we're going to put this under square root. So that will give us 31.3 meter per second. That's the initial speed of this object when we throw it upward to reach the maximum 50 meter height. Now, the second part of this example is how long will it be in air? So here we're asking you about the total time for the entire process. So it will reach from the ground to the maximum height. That's the time to reach the maximum height. Then the time from the maximum height to the ground or back to the original point, that is the total time in air. So let's do it this way. I can choose that V final equal V initial plus gravity acceleration times t. I know this is 0. We just found how much is the initial speed, minus 9.8, sorry, and we need to find how much is the time to reach the maximum height. And again, just by rearranging the formula, that will give me the value of 3.2 seconds. Now here, to reach maximum height, but to find time on air, which means going to the maximum height. So if I start from here, it's going up to the maximum height and coming back. That will be double the time required to reach the maximum height. So it's 2 times, sorry, let's fix this one. It's, sorry, and 3.2 And here, that will give me 6.4 seconds. That's the time we need, or this object needs, to stay on air to do this part. Now, I could solve the second part of this example in a different way by using one of the other kinematics equation, which is I can start another page and I can say, all right, I'll pick this one. It's the V final equal V initial plus half the gravity squared the time. Now again, this is 0. The initial velocity, it's 31.3. Once again, sorry about why it's keep doing this. And we don't know how much is the time. Here we can say it's 4.9 because it's half the 9.8, and it's t squared. Now I can rearrange my formula and it will look like it's a quadratic equation. V squared and plus 31.3 t, and that will equal 0. Now just following the quadratic mathematical method to find how much is the time, we will find that t, it could be equal 0, and this one is impossible because the object really took time to reach the maximum height and come back to the original point, or t will equal 6.4 seconds, which is exactly what we just found in the previous way, which is just here. All right? This is one of the examples related to motion in one dimension, but in the y-axis or vertically. I will see you again with another video. I hope you find this video useful, and I'll see you again. Thanks.